Everybody, welcome back to another fun and exciting geometry class. Today we are going to be on lesson 3.13, and that's on page 148. 3.13, and we're going to be talking about measures of angles in a circle. This is kind of like a transitional lesson. We're going to be talking about this, has a lot of vocabulary in it, and then that's going to kind of launch us into the next section that we'll be going through. Um, all right, so there's a ton of text in your book. This lesson has actually probably some of the most text of any of the lessons in your book. So I'm not going to take time to really go through it, talk about it too much. I'm just going to kind of highlight some of the key things there. One of the things is you need to know. It says there, and I didn't write this word down, but it has talks about numerical measurements. We're talking about when you measure something with numbers. Now, you're not actually measuring it with a number. Like, let's say you're going to measure the table and you use feet or you use meters. Well, the meters and the feet, that's the label that you're using, but then you have a number with it. So it's like 17, you know, feet. That's a big table. Inches, feet, all these different things, pounds. But you're assigning a number to it. So it's how many pounds. There's a number that goes with the pounds. That's the numerical measure, the number measure. Well, in a circle, we have the same thing going on. We have number measurements. And those number measurements, we call those degrees in a circle. The way that you figure this out, some of you have wondered how they came up with degrees and how they came up with those things. Well, in essence, it is a division of the circle and it's a ratio of the circle. And here's the ratio. You take the diameter and you take the curvature of the circle, and it's right there about halfway down. You'll see it kind of talks about some things. And so you take the circumference, the curvature, the round part, how long it takes you to get around the circle, okay? And then the diameter, and you use that ratio, and you come up with pi, 3.14, 159, blah, 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 blah. We could keep going on with pi all day long, but the thing that I want you to understand about that, before we really go any further into these the degrees and different things, is that is an irrational number. Okay, pi doesn't have, you can't like, pi never comes out evenly, so you can't express a circle in regards to an even number. So every time we're talking about degrees, or every time we're talking about really any measurement in a circle, other than the actual length of the diameter or something like that, anytime you're talking about the circumference, you have to use pi, and so you're rounding it off, so you're never going to come up with exact measurements. And that's the difference between rational numbers and irrational numbers. Irrational numbers means they don't really come out evenly. It's a repeating decimal. Okay, so let's go down here now. Let's look at what I have on the screen. The next, this is on page 149. It talks about these two words, commensurable and incommensurable. Okay, now not measurable, but the word it comes from the same root. But here's the idea. Commensurable, it means that two magnitudes with a common unit of measurement. Or in other words, you're dealing with two things that are the same. It's like comparing apples to apples. Okay, they might be a little bit different. Okay, one's a green apple and one's a red apple, but we can still compare the apples to apples. Incommensurable is when you have two magnitudes without a common unit of measurement. So now we're talking about apples to oranges. We're talking about two different things, and we can't really compare them because they're two different things. Can we make some comparisons? Sure, but we can't really put them into, like when we're talking about these numbers, we can't put them into a ratio. We can't figure them out. With degrees, what we've done with degrees, what mathematicians have done with degrees, is they have divided degrees into angle degrees and arc degrees. Now, They're different. This is like red apples and green apples, okay? But they're both still apples. They're both still degrees. So they're commensurable. And mathematicians have done this so that we can measure circles in two different ways. We can measure the inside of the circle with degrees, or we can measure the outside of the circle with degrees. Okay? Now, in this case, what we're looking at, I'm going to zoom in on this just a little bit. Okay, so what we're looking at here is an angle, and this is a very specific angle. I'm going to call this a 1 degree angle. Okay, this is 1 degree. Now, it's not 1 degree. It's probably more like about 3 degrees, but I've made it so that you can see it. I don't want it to be so small that you can't see it. We're going to pretend like this is 1 degree. If we put our protractor on this, it would probably be more, but we're going to pretend like it's 1. Now, what does that mean? That means if we put another one, well, let me try to do a little bit better than that, then this would be, this would be 2 degrees. And if we did another one, this would be 3 degrees, and 4 degrees, and 5 degrees, and 6 degrees. And we could keep going all the way around the circle until we got to what? Okay, until we got to 360 degrees. There are 360 degrees in a circle. Now, that's the inside. That's starting at the center point. Now, let's talk about this point right here, which is an arc. What we could say is, if we blow this up even just a little bit more, that this point to this point is 1 arc degree. 1 arc degree. Now, that's different than an angle degree, but it's the same. What do I mean, different and the same? Well, it's the same because, look, that equals that. 1 equals 1. The numerical measurement is the same, but they're different looking. Look at this. This looks like this looks like an angle like we're used to with a degree, okay? And over here, this almost looks more like a measurement that we could measure, like we could take a ruler and measure that. This, we would have to take a protractor and measure it. So they're different but the same, okay? Arc degree and angle degree. But if the angle is 1 degree, the arc degree is 1 degree. And that's there in your book. There's a little brown box there on page 149 that says that. The numerical measure of an angle is equal to the numerical measure of its arc. They're equal to each other. Now let me show you something else right here. Erase. Oops, didn't want to do that. Let me erase this real quick, and then I'm going to show you one more thing. All right. So let's put another angle in here. And we'll put a little bit bigger angle, and I'll just make up a number right here. I'll call this, what does that look like? Let's call it 40 degrees. Okay, so then this would also be 40 degrees. Now I want to show you something. If I take another circle, I'll put a yellow circle in here. All right, now I got a yellow circle here. We're going to pretend something. We're going to pretend like they're concentric. Now, they're not perfectly concentric because my program here doesn't allow me to do that. But I want to show you something. If this angle right here is 40 degrees, and we said that it was, notice how the 40 degrees doesn't change at the central angle. So it looks the same in the yellow circle, this one, and it looks the same in the white circle, the big one, okay? The angle didn't change. Now look what did change. This measurement right here, let me kind of change the color here. This measurement right here and this measurement right here. You say, Mr. Steve, that can't be the same because obviously this one on the outside is much bigger than the one on the inside circle, okay? Now I know the length of this is bigger than the length of this. However, they both have 40 degrees of arc angle. Those are both 40 degrees of arc angle. Why? Because the central angle is subtending that. And we could keep going out and out and out with bigger concentric circles. And but the arc degrees don't change. What does change is the length of the circumference, okay, or the length of the arc of the circle. That changes, okay? But what doesn't change is the arc degree right there. All right, hope you followed that. If you didn't, read it in the book, maybe you'll follow that a little bit better, but hopefully you understood some of that. All right, page number 150. Page 150, we'll talk about the secant, just a little bit about what that looks like and some other things with it, and then we'll be done with this lesson. A secant is a straight line that cuts the circle. That's on page 150. So, for example, the book shows you something that looks like this. Now you say, no, that's a tangent. No. Remember what a tangent is. A tangent is something that touches the circle on the outside and it only touches it once. You say, no, that's a chord. No. A chord is something that starts on the circle and ends on the circle. This does look a lot like a chord, but notice that it cuts the circle. And so it does touch the circle twice, but it cuts all the way through and then it continues. This is called a secant. Now, a couple things about the secant. Let's see. Let me talk about these points right here. So where it cuts the circle. We can name these. We'll name these A and B. Okay. So points A and points B. Those are just points on the circle. Now watch what happens here if I connect these using a chord. And now what happens if I go around this on my arc? Okay, so this has a name. What is its name? This is called a segment of the circle. It's right there on page 150, a segment. Now, it's not a semicircle because this is not a diameter. If it was a diameter, this would be a semicircle. So when it's just a part, so it's just this part of the circle, okay, this little top part, and it's the secant is going through there, and then you count this little shape. That little shape right there is called a segment. Now, the next thing here is what if we add another secant? For example, we do something like this, and now we have point C. Okay. So now look what we've created. We've created an angle right here with A. Okay? And actually, if we connect those, we've created a triangle. And we can talk about that in a little bit. But I want to talk about the angle that we create. This angle A that we created with two secants going through the same point A. What we've created there is it's called an inscribed segment. This segment right here, and we'll call this C down here, sorry. This segment right here is called an inscribed segment. Okay, so if we cut that off right there, this segment is inscribed. What does that mean? Well, it's inscribed by this angle is inscribing it. Look, this angle right here is inside the circle, so it's inscribed. And so that would be an inscribed segment. Let's see, what else? There's just a couple other things there that I want you to know, and that's a major segment and a minor segment. Let's go back to this real quick. This segment right here is a minor segment. Why? Because it's less than 180. But if we're talking about this segment here, then this would be a major segment because it's more than 180. Okay? So minor segment, major segment. The smaller ones, smaller than 180, would be minor, bigger than 180, major. I think that's all I have for you in this lesson. The important parts to this lesson are that you understand the basic functions of the arc degree and the angle degree in the circle, and then you understand the segments and you understand the secants. If you kind of get those, and then I talked about inscribed angle segment. Yeah, I hit all that stuff. Okay, good. If you understand those, then we can go on in the next lesson to kind of talk about how these work and how we can use them to do proofs and how we can use them to do other things in the circle. So Make sure that you go back, rewind any of that you missed. Make sure you know those words. Look in your book on page 149 and 150. Obviously, if you have any questions, you can always message me and ask me that question there in the comments. All right, well, that's all I have for you today. See you later. Bye-bye.